In this question, we are told do not use a calculator in answering the question. So it is given that function of x is equals to 2 minus sine of 4 of x. So in the first part, for 1 mark, we need to integrate the function of x with respect to x. So let's look at how to do that. So first of all, let's replace the function of x with 2 minus sine 4x, okay, as shown here. Then 2, if you integrate with respect to x, it's going to become twice of x, so 2x, and minus sine 4x if you integrate. Okay, but before you can do the integration, we should know that if you differentiate a 4x, you should get a 4 in front. So 4 sine 4x is easier to integrate. And of course, in order for me to introduce a 4 here, so I put a 1/4 outside. So 1/4 integral of 4 times sine 4x dx. So now it is easily integrable. So that's a 2x. So this negative 1/4, I'm just going to keep it as it is. F prime x sine fx, if you integrate, it's going to simply become cosine of 4x, and this 4 is over here, right? And of course we need to include a plus c, which is a constant of integration. There we have the integral of function of x integrated with respect to x. Let's now look at part 2. Part 2 says integrate x times function of x with respect to x, and this has a limit of 0 to pi over 2. So let's replace the function of x with 2 minus sine 4x. So we have x times 2 minus sine 4x dx. So now we need to, in order to perform the integration of this, we need to perform integration by parts. So let's call the u as x, and let's call the dv dx as 2 minus sine 4x. So this is easy to differentiate and this is easy to integrate. So therefore we're going to differentiate u. Okay, so we get a du dx. Of course, x, if you integrate with respect to x, it should be a 1. So let's now integrate dv dx, which is 2 minus sine 4x. So 2, if I integrate, it's going to become 2x. So my v will therefore be 2. If I integrate, it's going to become 2x. And minus sine 4x, if we integrate it, it's going to become cos 4x over 4. Of course, we have already done that for the first part, so we could have just simply taken that and plugged it here. So that should be our v. So now that we have our u, v, du dx and dv dx, now we can start to integrate this function by using integration by parts. So the formula for integration by parts is u times dv dx with respect to dx is equals to u times v minus v du dx dx. So now let's take all of these values and let's substitute into each and every one of the variables here. So our u is of course x, so I'm going to start with a u. So u is a x, and my dv dx is of course 2 minus sine 4x. So there we have, and then we have a dx. So now you can see this is exactly the same as this. So and this should be equals to u times v. So what's my u? U is of course x, and what would be my dv dx? So the derivative of u, derivative of v, which is dv dx, is 2 minus sine 4x. Oh, sorry, this is v, sorry. So this should be 2x plus cos 4x over 4 and minus, okay, and we have the integral sign, and we need to put in our v, which is 2x plus cos 4x over 4. So let's write that. Okay, actually I have written the du dx first, but anyway, it doesn't matter, u times v times du dx or du dx times v, they are both the same. So that's my v, and then multiply by dx. So there we have it. So now we need to evaluate this expression. So let us first simplify these brackets. So 2x times x is going to become 4x, and because I want to write a 4 as a common denominator, so if I multiply the 4x with a 4, so wait a minute, 2x squared times a 4, that should become 8x squared. And of course x, if I times it by the cos 4x, this would become x cos 4x. Then the whole thing divided by 4 minus, then let's now integrate this. 2x, if I integrate with respect to x, is going to become 2x squared over 2. And later part we can just cancel the 2 and the 2, or we could combine them with a common denominator. Now for this part, okay, for cos 4x, I'm going to pull out a 4, and because I'm going to write 4 cos 4x inside, so of course I divide it by another 4, so that would make it 1 out of 16 times 4. Okay, actually if you throw this in, so this would actually become 4 over 16, which would be 1/4, which is the same as this, right? So we have 4 cos 4x. This is already nicely expressed of the form f prime x cosine fx. So when we integrate 4 cos 4x, what are we supposed to get? Okay, before that, let's just copy down the rest of the terms, and this part we could convert it into a 4 so as to combine these two fractions together. So 4x square plus, okay, x cos 4x. And how did the 8x square become a 4x square? If I change this into a, if I multiply the numerator and denominator of this fraction by a 2, so this would become a 4x square over 4. And of course from 8x square, if I subtract the 4x square, and that's how it became a 4x square here. And then the x cos 4x I have just copied down as it is, and I didn't do anything, and the whole thing over 4, so therefore this term does not exist anymore. So you've got the minus 1 over 16. Now we are ready to integrate 4 cos 4x. So if we integrate the 4 cos 4x, it's going to simply become sine of 4x, right? So sine of 4x, and therefore, okay, now we have got the limits, so we have already done the integration. So now with the limits, we need to substitute the limits. So what I have done here is, here I have a 16 and here I have a 4. I've expressed them to a common denominator of 16 so as to combine it. So in order to do that, in order to convert the first fraction to have a denominator of 16, I multiply the numerator and denominator by a 4. So 4 times 4x square, that's how it became 16x square here. And then 4x times 4, x times 4 became 4x cos 4x, which is this particular term here. And minus sine 4x is here, okay, and divided by 16. And we just put in the limits, which is 0 to pi over 2. So which I have just copied down from here because it is given in the question to integrate from 0 to pi over 2. So now all that is left of us to do is to just substitute the limit. So let's substitute the upper limit of pi over 2 for all the x. So we're going to have 16 times pi over 2 squared plus 4 times x. So x replaced with the pi over 2, and cosine of 4 times pi over 2, which is of course going to be reduced to cosine 2 pi in the next step, and cosine 2 pi of course would become a 1. So sine 4x would be sine 4 times pi over 2. So we have substituted the upper limit for all the values of x with the pi over 2, and now we're going to go for the lower limit, which is 0. So 16 times 0 squared, okay, that's what we have here, and 4 times 0, cosine 4 times 0, okay, and then sine 4 times 0, which is over here. So now let's evaluate this. So this would be 16, this is going to become pi squared over 2 squared. 2 squared is a 4. So if I cancel the 16 and the 4, it would just give me a 4, and then I've got my pi squared. So that's how we got the 4 pi squared. And cosine 4 times pi over 2 would become cosine 2 pi. And 4 and the pi over 2, if I simplify it by cancelling the 4 with the 2, so I get a 2 pi, right? And this bit here, so 4 times pi over 2 would of course become 2 pi. So sine 2 pi in the next step is going to become 0, and cos 2 pi in the next step is going to become a 1. So that we will do it as another next step. So let's now go to the second bracket. So 16 times 0 square is of course 0, and 4 times 0 is going to be 0, therefore the whole thing is going to become 0. This entire term is going to become 0, and sine 4 times 0 is actually sine 0, and sine 0 is of course a 0. So therefore you have a 0 plus 0 minus 0, which is of course the entire second bracket is going to become 0. So now let's simplify this. So cosine 2 pi, as I mentioned, it's going to become a 1. 1 times 2 pi would become 2 pi, and sine 2 pi is of course a 0. So the first bracket is going to have only 4 pi squared plus 2 pi minus 0 over 16. In the second bracket, it's of course completely going to become just a 0 because everything is 0 on the numerator. So now we can reduce this. So what we have is 4 pi squared plus 2 pi over 16. Okay, minus 0, we can just ignore that. So in the 4 and the 2, there is a common factor of 2, so which I can pull out the 2 and cancel with the 16. So I get a 8 in the denominator, and of course, okay, 4 pi squared would now become 2 pi squared, and 2 pi would have just become a pi, and therefore if I just factorize out the pi, so what I will have in the bracket is simply 2 pi plus 1 unit square. So that is how we perform the integration of x times function of x dx from 0 to pi over 2, and that should give us 4 marks. So let's now look at part 3 now. So in part 3 we are told to integrate function x squared taken from 0 to pi over 2. So now let's first substitute the function x with 2 minus sine 4x, and then there's a square given in the question. So I am just putting in the square. So let's now expand this in the next step. So we can use a squared minus 2ab plus b squared, that formula. So 2 squared, that's a 4. 2 times 2 times sine 4x is going to become 4 sine 4x. So because this is a minus sign, so there's a minus sign here. And then minus sine 4x, if you square it, it's going to become plus sine squared 4x. So that's simply the expansion of what's in the bracket. Now we can simply integrate this too, but for this sine square we need to convert it into in terms of cosine double angle formula. We will do that later, or we can do it now. From cosine 2a, as we know from the identity, this should be equals to 1 minus 2 sine square a. Now let's make 2 sine square a the subject. So if I throw the minus 2 sine square a to the left, it becomes positive 2 sine square a. And we have got 1 cos 2a. If I throw over to the right hand side, it's going to become 1 minus cos 2a. So now the next step is I'm just going to just isolate the sine square a, and I'm going to start dividing everything by a 2. So 1 if I divide by 2, it's going to become half, and cos 2a if I divide by 2 is going to become half cos 2a, and which is of course equals to 1 minus cos 2a over 2. So we have nicely expressed sine square a in terms of cosine double angle. And if you compare this with this, so if your a can be replaced with 4x, now we could be able to simplify that and express it in terms of cosine of 4x, which is actually going to become cosine 8x. So I'm just replacing the a with 4x. So sine square 4x is going to simply become 1 minus 2 times 4x, that would become 8x, and then the whole thing divided by 2. So this is the substitution I'm going to do for this. So sine square 4x is therefore equals to half minus half of cosine 8x. So now let's replace this identity here, okay? And so I have just replaced the first two terms, and for the sine square 4x I'm going to just replace with this. So I've got half minus half cosine 8x dx. Now this 4 and the half, they are both numbers, so we could combine them and we can write it as, okay, 4 and a half, which is basically 9 over 2, and this minus sine 4x I have just copied down as it is, and I didn't do anything. So the minus half 8 cos x, just simply copy that down as well. So that is the next step. So now we need to integrate this. In order to integrate, so 9 over 2x, 9 over 2, if you integrate it, is just a constant, so it's quite simple. So it becomes 9 over 2x, and then we have got a minus 4 sine 4x. So minus 4 sine 4x can be directly integrated into cosine 4x, and of course I'm just going to put in my limits to 0 to pi over 2 here, and this part is 1 over 2, but of course if I differentiate the 8x here, so that's going to give me a over 8. So that 8 and the 2, I have put them together and write it as 1 over 16, and cosine 8x, if I integrate it, it's going to become in terms of sine. But anyway, so what I have done here is, instead of going into the integration, so I just wrote it as 1 over 16, and inside I left the 8. So you can see 8 and 16, if you cancel, you will get back the previous step, which is half. So now this part, 9 over 2x cosine 4x, okay, with the limits of pi over 2 to 0. And then here I have got a minus 1 over 16 outside the bracket, and this part is supposed to give me minus sine 8x, and because of this minus sign, minus is going to turn this into a plus. So therefore I have written a plus 1 over 16 sine 4x. Cosine, if you integrate, it's going to become negative sine. So there we have it. Now all we need to do is just substitute the limits. So I'm substituting the x with a pi over 2, and then for the cosine also I'm going to just replace the x with a pi over 2. So there we have the upper limits substituted, and then we write this part is 1 over 16, okay, sine 8x, and then I have also substituted the upper limit of pi over 2 and minus away. Let's now throw in the lower limit, okay, 9 over 2 times 0, okay, plus then cosine 4 times 0, and then plus 1 over 16 sine 8 times 0. So there we have all the terms simplified here. So now let's simplify further. 9 pi over 2 times 2, that's going to become 4. So it will be 9 pi over 4. So cosine 4 pi over 2, 4 and the 2 you can cancel, we're going to get cos 2 pi, and of course cos 2 pi in the next step is going to become a 1. So we have a 1 over 16 sine of 4 pi. 8 times pi over 2 is 4 pi. And if you look at the second bracket, 9 over 2 times 0 is of course a 0. Cosine 4 times 0 would be a cosine 0, which would be equal to 1. 1 over 16 times sine 8 times 0. Sine 8 times 0 will become sine 0. Sine 0 is of course in turn is a 0. Okay, and 0 times 1 over 16 would also become 0. So the last term will simply disappear. So if you want to be faster, so you could just jump step and you can just write a 0 here straight. So the 9 pi over 4 is going to stay as it is, and cosine 2 pi is going to become a 1, and 1 over 16 sine 4 pi. Sine 4 pi is of course 0. So 0 times 1 over 16. So here in the second bracket, so the 0 I can ignore it. Cosine 0 is a 1, and 1 over 16 times sine 0 would be 1 over 16. Sine 0 would be 0. So this plus 1 and a minus 1 I can cancel. So 1 over 16 times a 0, and here also I have got 1 over 16 times 0. So it can all be cancelled away because they are all zeros. So what is the only thing that we have left now? 9 pi over 4. So the answer for this is 9 pi over 4.